Hey guys, it is Mr. Bicen, and we are here for another live stream. We have got probably just one more live stream after this in this exam season. We've got one more live stream to go, and that one is, of course, going to be the night before the exam. I know a few people have been saying, what are we going to be doing in that last live stream? Well, rather than doing a full paper, I'll probably pick 3 mechanics, 3 statistics questions on what I deem to be some of the more like challenging kinds of topics. I'm thinking things like moments, projectiles, forces, that kind of stuff for mechanics. And for statistics, there's got to be some normal, there's got to be some binomial, and then maybe like a tricky kind of probability kind of question that we have there. So what I wanted to do is I wanted to do a little poll, because I haven't done a poll for a while. I might do the poll tomorrow will be about the mantras, which I've already been getting some good ones for in the live stream that I did yesterday, which was on mechanics, which is available. The poll is going to be, let's decide once and for all, which is better, mechanics or statistics? So if you do want to tell me what you think, I've not given any option for you to get out of this. I've not put pure in there. There was absolutely no way I was going to put pure in there. I wanted to make sure that we were just sticking with the big ones for this, okay? Literally just which is better, not easier, which is better. And I'm obviously like super duper biased for this kind of stuff. So have I got everything I need? If you could see the rest of my desk, it is chaos. There is paper everywhere. I've literally got 3 calculators on my desk right now. I've got 4 pens, 3 baseball caps. What am I doing? Anyway, let me try and get from this massive pile of stuff. Let me try and get my formula booklet, because I know I'm probably going to need this for statistics. I am going to be getting my CG50. New kids are going to be using the CG100. You guys are on the CG50. I don't have a class whiz, so I'm not going to be able to do that. I'm definitely not showing you my messy desk. Okay, I want you to think Mr. Bicen is all tidy and organised. And I will be after this, because I'll do a bit of a tidy up and trying to make things a little bit better. So mechanics is absolutely dominating right now. Over 2/3 are team mechanics. I mean, you know where I am for this. You absolutely know where I'm at with this. The reason I always have 3 baseball caps here, not always 3, but I always have at least 1. I've got this other one that says Felix the cat, because my nephew is called Felix. I have twin nephews who I love. It's because it's so sunny where I sit that sometimes I need to get the sun out of my eyes. Anyway, I'm hoping at some point my sister is going to make an appearance, and I'm hoping that my mum is going to make an appearance. My sister's always wanted to come along to one of these live streams, and yeah, maybe she'll be in this one. And I know she's with my mum right now, so they'll probably join together. Oh, there she is. She says she's here. Do you guys see her in the chat? My sister is so talented. If you Google her name, you will see the most insane art that she does. She is an incredible artist. In fact, you can go to her website. Her art is absolutely stunning. Portraits of people. Claudia Bicen. She goes by Bicen. I don't know why I go by Bicen. It is Turkish, so it should be Bicen. But yeah, you can go and check out her art, and you'll see how it is. So we've got Sister Bicen. Mama Bicen is there with her, but she's probably my mum's probably looking after the twins. The twins are 3.5, and you can imagine what 3.5-year-old twins are like. Anyway, today in the live stream, we'll be doing the 2022 statistics paper. Don't get me started on 2022. I believe this is probably what the statistics paper was going to look like. It's probably not going to look like this, but statistics is pretty much the same every single year, the same kinds of topics that we've got here as well. Someone said that they see Rose Bison in the chat. Did I miss my mum? Was I just... Yeah, there she is. She says she's here too. They're both here, which is amazing. I've had no updates from EdXL at all. No updates for this of what's going on. All we're going to do is just our best to be prepared as possible. And there might be some curveballs. There's some pretty like sneaky questions in this paper as well. But we'll just talk through the theory, have you kind of as prepared as possible, and we'll do a few more questions in tomorrow's live stream. This live stream should last about 1 hour. So I imagine we'll be finishing at 6 o'clock. My plan tomorrow is to probably do it about 3:30, I think is the time I like to do them, because they're usually a little bit longer the day before the exam. And I like it that people have some time afterwards to either do a bit of practice or to get on with relaxing before their exam. So we are going to be doing the 2022 statistics paper. Of course, when we do this paper, I will put the annotated version of it afterwards. Thank you very much to Grace. Oh, that's such a cute little A little dancing pair. That's so cute. Oh, that's very nice. Okay. I haven't finished Further Stats 1, by the way, but it was hard. From what I could see, it was really hard. As soon as you look at this topic, tell me in the chat what you identify this topic to be. There's a few key things that are jumping out to me that make me immediately know what this topic is going to be. And as classic, that means it gives me a chance to pour myself a glass of water. Guys, I've been having like a complete nightmare of a day with technology, so I'm relieved this live stream is actually happening because I've had just a day of technology going wrong. I can see it all in the chat here as well. We've got binomial. Of course, this is binomial that we've got here. So George throws the ball at a target 15 times. Each time he throws the ball, the probability is 0.8. So obviously we've identified that we've got n here. And then, of course, we've got the probability for this part. The random variable x represents the number of times George hits the target in 15 throws. And we're going to find out the probability that x is 3 and the probability that x is greater than or equal to 5. And now we've got an even nicer dancing pair from Grace. Thank you so much. That is so kind of you. So they've already told us that x is the number of times that George is going to get it. We know it's binomial. Let's go straight in and say that it's going to be the 15 and the 0.48 that we have for this question. And so we are now going to go straight in and calculate the probability that x is equal to 3. You can just do this straight from the calculator. I have started getting into using distribution mode on here. If you don't use distribution mode, what are you doing? I wasn't using distribution mode for such a long time. But when I do distribution mode, I still do it with the upper and lower bound anyway. If you're doing this on the ClassWiz calculator, you would do this with PD, not CD, okay? But if you're doing it on the graphics calculator like I will be doing, we can just go straight in with what the answer should be. And I believe, if I've done it correctly, it is 0.197, 197 to 3 significant figures or 4 decimal places for this first question that we've got here. I'm not going to do that shout out, but that has really cracked me up. That has really cracked me up because I didn't want to, I want to check. That is brilliant that your teacher didn't teach you that and then it never came up. Okay, we have the probability that x is greater than or equal to 5. Well, if you have the non-graphics calculator, you have to rewrite this. I always think to myself, this is like 5, 6, 7, 8. In other words, we're removing everything that is less than 4. So it's 1 minus the probability that x is less than or equal to 4, and you do that calculation. But because I have the graphics, I'm literally just going to say that my lower is 5, and I will just say that my upper is 15 for this, okay? So I'll do from 5 to 15, and we get to 3 significant figures, 0.920. I've never really realized, but it was 3 significant figures. You'll see me often doing 4 decimal places for this kind of stuff. You don't get penalized for it, not like in mechanics or anything like that, okay? Now we're going to have a look at part B of the question, where it says George now throws the ball at the target 250 times. So make sure that we've clocked that it's changing to 250 instead, but the probability I'm sure is going to stay the same. Use a normal approximation to calculate the probability that he will hit the target more than 100 times. So we want to find out the probability that he will hit the target more than 110 times. Now, when you do the normal approximation, we're going to change it from x to y. Don't worry too much about the letters. It is in the formula booklet, but it goes NP and then NP1 minus P. You can find that in the formula booklet. So NP is going to be the 250 times by the 0.48. Let's get one of my 3 calculators here. That's the 250 times by the 0.48, which is 120. So we've now got the average for the normal distribution. And because I've already got that NP there, I just need to multiply it by 1 minus P, or 1 minus 0.48, which is 0.52. 0.48 and 0.52 are numbers that will haunt people because of Brexit. 42, is that right? Yeah, 48.52. I think that's what the percentage was for this kind of thing. So be careful. When you type this on the calculator, that's going to be mu, but sigma is going to be the square root of 62.4, and I can already see that people have said this. Now, my standard way for doing the continuity corrections is to say, okay, let's first of all change this to an or equal to one. Greater than 110 is greater than or equal to 111. And once I've got it written like that, I'm then going to change the range. I want to know what you guys think this number is going to have to be here. That's cracking me up. So on EdXL is going to put another quartic in the paper. you actually want it to go down to 110.5. The reason we want it to go down to 110.5 is whenever I do the continuity corrections, I want to make that range just get a little bit bigger. So at the moment it's saying 111 or bigger. Let's just go a little bit below that to just expand the range. When we do the continuity correction, we're always making that range just a little bit bigger. So I'm going to go onto my normal distribution, and I know you know how to do this, so that's why I'm not doing too much of a description about what's going on my calculator for this. But I am saying that it is greater than 110.5. If you do have an upper, you can just put in a really, really big value for this. Square root of 62.4 and 120. And we get 0.885 to 3 significant figures. And this is, again, where I hope I haven't made any mistakes with this kind of thing. So what I'll do is, as we go, I'll check these answers. So we're looking for 0.0197, 0.920, and 0.885. So we do have the 0.0197, the 0.920, and the 0.885 for this question, okay? Now, I don't know, has anybody done the 2024 paper recently, and it actually had a normal approximation on the first page? I did the normal approximation, obviously did the 2024 exams. I wrote to the examiner in the exam and I was like, why are you asking students to do a normal approximation? Because in 2024, it didn't have a probability that was close to 0.5. I think the probability was like a third or a sixth or something. And obviously I want to draw this to your attention right now. In order to do the normal approximation, we want the value of n to be large and we want the value of p to be close to 0.5. So I thought it was really, really weird in 2024 that they asked for us to do a normal approximation. Tell me your thoughts when you see this, when you turn the page. Tell me your thoughts. Yeah, I know. I don't know why I wrote to the examiner. I was feeling really cocky, I think. I was like, why have you done this? This doesn't make any sense. Why are we doing normal approximation? Really, really silly. Yeah, classic. People are looking at this and they're just like, this looks horrible, really long, too much words, too much waffle. They recently have said, like, oh, we're going to write things as bullet points because we think it looks nicer. But I actually think it makes the question look even longer. So I don't know whether that's the best thing or not. But we're just going to extract the information. It says that the length, a manufacturer uses a machine to make metal rods. The length of a metal rod, L centimeters, is normally distributed. So immediately, L has a normal distribution with a mean of 8 and a standard deviation of x. Put it as x squared because it's the variance. I'm not going to read the rest of the question. I'm just going to read this part that says, given that the proportion of metal rods, so in other words, the probability that a rod is less than 7.902 is 2.5%, which is 0.025, show that x is equal to 0.05 to 2 decimal places. So what is the technique? What's the thing that this question is actually asking for us to do in this one? Yeah, good. Doritos King is coming in again with this is going to be using standardization, or like missing sigma, missing mu, that kind of stuff. Yeah, Mama Bicen is back alongside the true Mama Bicen and Sister Bicen as well. So, because we can't type this into the calculator to find out what x is equal to, because we know that L has this normal distribution with a mean of 8 and this, we're going to have to do it with z instead. So I'm going to figure out what is this z thing. Obviously, when we do z has a normal distribution with a mean of 0 and a standard deviation of 1. So I'm going to find out this value, and I will do that by using the inverse normal distribution. However, you can do that on your calculator, whether you do it in distribution mode. There's quite a few different ways of doing this right now. So I'm going to be saying that it's less than something is 0.025. So the area is 0.025. Sigma is going to be 1 because we're doing it for z, and mu is going to be 0. And this number is minus 1.9599, like this, okay? So this now means that if I want to go from L to Z and from this one to this one, I am standardizing. And the way that you standardize this is you take L, you subtract the mean, and you divide by the standard deviation, and that gives you Z. So I'm going to just do that pattern, but I'm going to do it for these numbers that are right here, okay? So I'm going to take the L number, I'm going to subtract the mean of the L number, and I'm going to divide by the standard deviation of the L number, and that is going to standardize to give me the Z value. That's why we often call these things Z values. So all I need to do is solve this equation. I will do, on my second calculator, 7.902 minus 8. that is minus 0.098 equals minus 1.9599x. So I will divide that by 1.9599, and we get that x is equal to 0.050000. In other words, 0.05 to 2 decimal places. Obviously, don't write on that part of the exam because it's probably going to get not scanned in properly. So now we know what x is, we can move on with the rest of the question. Calculate the proportion of metal rods that are between this and this, 7.94, 8.09. So we're just going to be saying 7.94, 8.09. This is literally just, can you type on a calculator? I think I can, but let's hope we don't make any mistakes. So I have my 7.94, my 8.09, sigma we just worked out is 0.05, and mu is 8. So that probability is 0.849, and then there's loads of zeros. So I'm just going to go with that to 3 significant figures that we have for this one, okay? Now we get to the really annoying part of the question because there's so much text. It then says the cost of producing a single metal rod is 20p. A metal rod where the length is less than 7.94 is sold for scrap at 5 pence. It's a waste of money, but something's gone wrong with the machine, they can't sell it. When it is a good length between 7.94 and 8.09, they're like, cool, we can sell this for the proper price of 50p. When it is too long, when L is greater than 8.09, they will shorten it a little bit, which costs 10p, and then it gets sold for 50p. So there's plenty of ways of thinking about this, okay? My personal preference for this is to think how much profit does each of these scenarios actually generate that we've got here. So let's just begin by thinking about this yellow scenario, not forgetting about this. Does this make money? Does this lose money? What happens if a metal rod is there? Tell me what happens to a metal rod in that scenario. Very good. This is a 15 pence loss that we've got here. So this is going to be a loss of 15p. You can think about the other ones, but I'm just going to go through them. If this is being sold for 50p and it costs 20p, this is a profit of 30p. And then what about the last one? What's this one going to be overall if it's got this extra cost that is going with this one as well, okay? I'm so pleased Mechanics is winning this vote. It's pretty brilliant. This one is only going to be a profit of what for the last one? This is a profit of 20p. They do actually make 20p for this one, okay? Because it costs 20p to make it, 10p to shorten it, but they sell it for 50p. So 50p, take away the 20, take away the 10 is 20p here. So what we need to do now is it says calculate the expected profit per 500 of the metal rods. Give your answer to the nearest pound. Well, I know something, right? I know that this proportion here, this proportion will make 30p profit each. So all I need to do is figure out what proportions there are for all of these things. So I'm going to say, what is the probability that L is less than 7.94? The probability that it's in between 7.94 and 809. And the probability that L is greater than 8.09. This one is the one that is a loss of 15p. This is a profit of 30p. This is a profit of 20p. A lot of thinking happens at the beginning of this question, and then it's just typing things in a calculator. So about 85% of them are going to be good, that 8.49 that we've got there. I'll now do less than 7.94, which is 0.1151 to 4 decimal places. I just need to get rough values for this. And now greater than 8.09 from the calculator is 0.0359, like this. So if you think about these as kind of percentages, right? 11% will lose 15p, 85% will gain 30p, and 3.59% will gain 20p. So the way I'm going to do this is just one single calculation, however you want to go about this. But I know that that percentage of the 500 that they are making will make a loss of 0.15, 15 pence. Then 0.849 of the 500, 84.5% of the 500 will make a profit of 30p. And then the remaining part, the 0.0359 of 500, will make a profit of 20p, and that will give me my final answer. You can do it in other ways, of course, but this is just the way that I kind of think about how I would do this question. So now I have to be very careful with how I type. 0.1151 times 500 times minus 0.15 plus 0.849 times 500 times 0.3 plus 0.0359 times 500 times 0.2. And they want it to the nearest pound. It's 122.3075, but this is 122 pounds. Now, there are plenty different ways of doing this, okay? There's plenty different ways of doing this. This is just my approach. You should still end up with the 122. Some people I know will do this, where they will work out how much money they sell it for, and then at the end, they will subtract 500 times by 20, because it costs 20p for each of the 500 ones that we've got here as well, okay? I feel like there was some chat from my mum in here, which is hilarious. I hope everybody was being nice to my mum. It looks like they were. Okay, good. So that was a huge chunk of marks for this question. And again, it's like starting off and saying to yourself, okay, I'm trying to find out how much profit they're going to make. What's profit? It's how much money they make. It's how much money they lose. I've got all of the proportions for all of these parts, and we go from there, okay? Mr. Bicen, is there going to be a D1 stream? I'm afraid there's not going to be a D1 stream. I'm very sorry. D1 and I are not the best of friends. And then I don't get how this one is 5 marks, and then suddenly the last part is 4 marks. I think the last part is really straightforward for 4 marks. The same manufacturer makes metal hinges in large batches. The hinges each have a probability of 0.015 of having a fault. So it no longer sounds like it's to do with the normal distribution, because we don't have standard deviation and mean. We have a probability. A random sample of 200 hinges is taken from each batch, and the batch is accepted if fewer than 6 hinges are faulty. The manufacturer's aim is for 95% of batches to be accepted. Explain why the manufacturer is likely to achieve its aim. Okay, so we can say, I can't remember what the question is doing. Okay, the probability is 0.015. There are 200 hinges, so n is 200. This is binomial. I can see that Maya has already said this is binomial. So it's binomial with 200 and 0.015. And it looks like they were saying, what's the probability that it says it is accepted if fewer than 6? What is fewer than 6 going to look like when I write this in the brackets? I'm going to start doing it on my calculator to save us a bit of time for this, okay? Fewer than 6. Very good. It's going to be less than or equal to 5. Number of trials is that. Let's go. And we get 0.91760. That's worth 3 marks, what we've just done there. I think that's worth 3 marks. It now says the manufacturer's aim is for 95% to be accepted. Well, it looks like at the moment we will have... It says, explain whether it's likely to achieve its aim. Well, this is 91.7. This is less than 0.95, so the manufacturer is unlikely to reach its aim. The manufacturer is unlikely to achieve its aim. Because it looks like they're only going to get 91.7% of them being accepted, but they wanted it to be at least 95%. Now, we don't know that they definitely won't, because it's probabilities. Anything could happen within reason, okay? So, let's double check we've got all this good. Did I already start this one? No, it's this next question. It's kind of hard to see all of these answers, but this was a show that, so we knew that that was fine. We did have the 0.849. We did have the £122. Lots and lots of different ways of calculating it here. And we have this part here. Okay? So let's go and continue. This is a 6 question paper. Mechanics tends to be 5, could be 6. Statistics tends to be 6, usually. Wait, it's everyone's favourite topic. We've got the large data set. This is actually one of the easiest large data set questions I've seen. Remember, you don't miss out on too many things with the large data set. So Diane uses the large data set to investigate the daily total rainfall, R millimeters, for Camborne. Tell me anything you know about Camborne, please. Please tell me anything you know about Camborne. And yeah, people are saying, how is this recorded in the large data set? It's recorded as TR for trace. Great, we've got loads of things. It's in the UK, it's south, it's near the coast, it's in England, it begins with a C. It's basically in the south of England that we've got here as well, okay? So that's all we really need to know, that it's down there in the south that we've got. So, this is easy. Diane uses the data for the 31 days. They've told us there's 31 days in August 2015 for Camborne, and calculates the following statistics. Calculate the mean and the standard deviation. I'm going to go quick for this, okay? So for B part I, the mean, which is R bar, which you really don't need to use, you could just go straight in with the calculation. It's going to be the sum of R divided by how many there are. That's 174.9 divided by 31. 174, I wrote 147. 174.9 divided by 31. This is 5.64 to 3 significant figures, and it's going to be in millimeters. I don't know if they need the units given, but it's perfectly fine if we don't. It says R millimeters, that's fine. Part 2 is the standard deviation. Now the formula for the standard deviation, I'm not going to ask you to type this, but it's going to be the mean of the squares. The mean of the squares is that, the sum of R squared divided by 31, minus the square of the mean. Now, because I've rounded this, I actually want to use this part instead, okay? So I'm going to do the 174.9 over 31 all squared. And in fact, I know what the sum of R squared is. Let's just put it in straight away. So that's 3, this is the thing I always get wrong, writing it down wrong. 3523.283. Okay, memorize the formula, type it in. Standard deviation, we obviously need the square root of this. The mean of the squares minus the square of the mean. Square root of 3523.283. I can't even type. I've done it wrong again. 3523.283 over 31 minus the square root of 174.9 over 31 all squared. And we get 9.0523 significant figures for this, okay? And it's still going to be in millimeters for this part that we've got here. Am I missing anything crazy? No, nothing crazy going on in the chat that's making me be like, why are people so obsessed with using my full name? My digital footprint has told you my full name. So Diane believes that the mean daily total rainfall in August is less in the south of the UK than in the north of the UK. It kind of makes sense in a way. You're like, oh, it's not very rainy in the south, so maybe it's going to be less rainy down south. The mean daily total rainfall in Luchars for August 2025, it is important to note that it's the same month, that could be something sneaky that they could switch up, is 1.722 millimeters to 2 decimal places. State giving a reason whether this provides evidence to support Diane's belief. Well, what do we know about Luchars? What do we know about where Luchars is as versus Camborne? We've kind of already discussed this already. I know people are talking about my like large data set. My large data set video has it goes like this all year. The videos go like this, the views, and then the day before the exam, the large data set video goes like and makes a huge jump. So Diane is wrong, okay, because it says state whether there's any evidence to support this. And if we compare the numbers, 1.72 and 5.64, there's actually more rain down south. So we just need to say, does it provide any evidence to support the belief? So I'll say no evidence to support the belief. As Camborne is south of Luchars, but has a higher mean. And if you want to, you can just make it really clear that 5.64 is greater than 1.72, which is what it was in the question for this. I actually got a train once and it went through Luchars and I was like, oh my god, I know where this is. We're in Luchars. And then everyone was like, why do you care? And I was like, it's in the large data set. And I was like, this is so stupid. Why am I bothering about this? Anyway, let's read the rest of the question. Diane uses the large data set to estimate the proportion of days with no rain in Camborne for 1987 to be 0.27 to 2 decimal places. So that's for the entire year that they've said that the proportion of days with no rain is 0.27. Explain why the distribution might not be a reasonable model for the number of days without rain for a 14-day summer event. Well, it's not likely to have a constant probability. Remember the binomial distribution, we want the probability to be constant that we've got here. Or you could say that it's unlikely that the 14 days would be independent of each other. But I think the most obvious one is if you're going to do it for the entire data set from 1987, well, how is that going to be useful for just a 14-day summer event? So I think we just need to say something like it is unlikely the probability will be constant for the summer event. Okay, that's probably what I would say for this kind of thing that we've got. Now let's have a look at the mark scheme and see if we did get these parts right and I didn't type anything wrong in the calculator. With the TR, you could write trace, and I think that would be accepted. Yeah, they do allow all of those different things for this. We had the 5.6 for the 9.05. Luchas in the north and Campbell is in the south. We described that. The mean is smaller for Luchas than Campbell, and therefore is no evidence. So they needed those kind of like two parts of it. I think we got that in there. And that the probability is unlikely to be constant. But just in case you want to pause this and read through, there are some other things that they would accept for this kind of stuff as well. Oh, am I pronouncing Luchas wrong? It's Lucas. Maybe we've got someone who's from Scotland and they know what's going on with this. Okay, halfway through, let's have a look at question 4 that we've got here, which is a dentist. A dentist knows from past records that 10%, as soon as I see percentage, I'm like, well, it's not normal distribution. 10% of customers arrive late for their appointment. A new manager believes there has been a change in the proportion of customers who arrive late for their appointment. A random sample of 50 of the dentist customers are taken. Write down a null hypothesis corresponding to no change in the proportion of customers who arrive late, and an alternative hypothesis corresponding to the manager's belief. Well, the null hypothesis for a binomial is going to be that the probability is 0.1. People are already telling me in the chat that it is two-tailed. The probability is not equal to 0.1. The reason it's not equal to 0.1 is because they haven't said that they think people are getting more punctual or less punctual. They're just saying they think there's been a change. In other words, they don't think that it's 0.1 that we have there. Someone said, how do I know it isn't normal when I see a percentage? Normal distributions will talk about means most of the time. They still might with percentages, because they could say something like the probability that something is bigger than this is 5%. But it's just when it's talking about 10% of customers arrive late, that feels like it's talking about the general probability for this particular situation here. So they've given us the hypotheses. We're now going to do for part B a 5% significance level. You have just told me that it is two-tailed, so the 5% I'm going to split into a 2.5% in each end. They also give you this clue by telling you that as well. Find the critical region for a two-tailed test of the null hypothesis in A. You should state the probability of rejection in each tail, which should be less than 0.025. Now, there's not actually any method marks for how you get this, so you can either use the formula booklet, you can use the calculator, but you just need to make sure that the probability in each tail is less than 0.025, and we need to write this down. I'm old school, and I like to use the booklet for this. So what we're doing here, X is the number of customers that are late, binomial with 50 and 0.1. Binomial, better check I'm in binomial. Yeah, 50, 0.1. So from the table, I can see the probability that X is equal to 0 is 0.0052. Okay, that's from the tables that we've got there, is 0.0052. And that is obviously less than 0.025. If you were to look at the next one, which is that X is less than or equal to 1, you get 0.0338, which is greater than 0.025. You don't get any method for this, so I can just get rid of that, but I might leave it in just for this part that we've got here. Do not do a normal, just don't do an approximation for this question, and only do approximations if it asked for it. So for the critical region, I know I've written critical region under there. Critical region is one of the things is X is equal to 0, or let's have a look at the other end that we've got here. That will be the top end. Now, this is where you might like to do it on your calculator because you do get the exact values, but I like doing this on the table. I like looking at the first one that goes above 97.5. The first one that goes above 97.5 is corresponding with 9. So this actually is telling me the probability that X is less than or equal to 9 is 0.9755, which means the opposite of that, the probability that x is greater than or equal to 10, is 1 minus this, which is 0.0245, which is less than 0.025. So this means the critical region is that x is greater than or equal to 10. You know, if you've seen my videos, when it's 9 from the table, I go like, oh, that's the first one that goes above 97.5. I'm just going to bump that up, and it goes to 10 instead for this part that we've got here, okay? So we've now got the critical region is x equals 0 and x is greater than or equal to 10. We have stated the probability of rejection. It was 0.0052 and 0.0025 for this part. It then says for part B, find the actual significance of the test, the actual level of significance of the test based on your critical region from B. So that means for this part, gosh, what must it be on now? Part C, I'm just going to add those two values that are underlined. So the actual significance level is, I got these from the calculator, I got them from the book, not the calculator. So they're only to 4 significant figures or 4 decimal places. Gosh, not that. 0.0245. 0.0052 plus 0.0245, and that is 0.0297, so quite low. Okay. So I did this from my tables, the printed tables that I've got right here, okay? If, though, you want to just do it using your calculator, you can do it whichever way. You can figure out how you're going to get what the probability is for that critical region that you've got there. With a graphics calculator, it's way easier because you can just keep trying different values until you literally get something that goes below 0.025 for this yet, okay? Wow, mechanics has really gone. 2/3 of people like mechanics. How many people have voted on this as well? 1,800 people. That's amazing. Okay, so I chose the 0.1 column because the probability was 0.1 that we've got here. It then says the manager observes that 15 of the 50 customers arrived late for their appointment. With reference to part B, comment on the manager's belief. Well, 15 people arrived late. That means 15 is in the critical region, which means, tell me about it. What can we do with the null hypothesis? Do we support the null hypothesis or do we reject the null hypothesis if it is in the critical region that we've got there? Yeah, we reject the null hypothesis, which means the manager's belief is supported. So for part D, 15 is in the critical region. So the manager's belief is supported. Now, I probably would write along a bit of context here. I probably would say something like, the manager's belief is supported. The proportion of people who are late to the dentist appointment is not 0.1 or has changed from 0.1, but I'm going to be a bit lazy for this live stream because I don't want to be on here for hours and hours and hours as well. Now, you probably have all bought some of my sessions already, but if you do like the way that I teach and you like the way I teach statistics, I do way more stuff for binomial and normal. I kind of organize the whole way that you should think about it in my Aiming for A-star session, which was run in the Easter holidays. It is now only £15, and you can find out all information about that in the description. It's like over 2 hours of a Zoom recording plus an hour's video of going through some extra questions you can try in your own time. It can be a really, really good way of you getting prepared for this kind of stuff as well, okay? So if you're interested in that, you can have a look at it. But most of the time, I just want you to be here for the live stream. This live stream has no adverts, I hope, because I don't like it when you are here with adverts. I want you to just kind of have an uninterrupted experience of looking at this stuff. Now, you might think, why is Mr. Bicen delaying? It's because I really don't like the wording of the next question that we've got here. Yes, by the way, someone said, can you do part B in distribution mode? Yes, you can do this in distribution mode. You can just like try different values until you get the probability going below the thing that you're looking for this, okay? Oh God, this question. Look at the writing on this question. Okay. I wonder if I might be able to change so I can see 2 pages at once. No, not at the moment. I might try that for another one because I really want to see both pages here. So a company has 1,825 employees. I'm going to write that down here because I just think that's useful information to have near this box. The employees are classified as professional, skilled, or elementary. The table shows the number of employees in each classification and the 2 areas A or B where the employees live. Easy to begin with, right? An employee is chosen at random. Find the probability that this employee is skilled. Okay, well that seems pretty easy. I'm just going to pick how many of them are skilled in total. So there's 275 plus 90. The other ones don't sound skilled then. So it's 365 over 1,825. You can actually leave it like that, but I will simplify it and it goes down to a fifth. Then we have the probability that they are in area B and not a professional. So they're in area B and not a professional must be those values. So that's 90 plus 80, that's 170. That's 170 out of 1825. It's best not to write your answers in the way I'm doing it, but because I'm on my iPad, I don't want to keep going like up and down and back and forth on all of this stuff. And then this is where the wording is just, I was about to swear, but it makes me annoyed, this does, okay? Some classifications of employees are more likely to work from home. 65% of professional employees in areas A and B work from home. 40% of skilled employees in both area A and area B work from home. 5% of elementary employees in both areas A and B work from home. Fine. I tell you what, I actually might do a bit of calculations up here and figure out what some of these things are going on, okay? So I think I can split this 740. I can do like a sort of a work from home. Let's do home and then not home. Home, not working at home. Home, and then not working at home, because it's the same proportion for area A and area B that we've got in all of these things. So I'm going to split this 740 so that it goes into 2 different bits. I'm going to do the people that are working from home, which is 65%. So 65% of 740. I know you're thinking like, why is he's not even read the question? I will tell you what the question is to complete the Venn diagram, but I want to start processing this information, because if I can get rid of all of these sentences and I can do some maths, the rest of the question becomes easier. And you've obviously got to use these things that we've got here. I hope I didn't get that last part wrong. Let's hope not. So we're going to do 65% are from home, but that's only for professional. 40% work from home who are skilled, but only 5% work from home who are elementary. So I'm going to find 65% of these, which is 481. And so if I do 740 minus that, that must mean that 259 don't work from home. I might not need all of this, but 40% of 275, that's 110 of those work from home, which means 165 don't. 5% of 260 is 13, so 13 work from home, which means 247 don't. And I'm going to do the same process over here. So 65% of 380. It might make my life easier. I hope it's going to do this. So that's 247, and not working from home is 133. 40% of 90 is 36. 60% of 90 is 54. 5% of 80 is 4, which means that must be 76. Now, I know there's an awful lot of numbers that you might not have to do it in this kind of way, but this is the most annoying part of the question. Event F is that the employee is professional. Well, why have they used F? This is so annoying. I'm going to go to this Venn diagram, and I'm going to say event F is professional. And I would honestly do this in the exam so that I know what things are talking about, okay? It then says that event H is that the employee works from home. That's like literally the only one that makes any sense. And then the event R is that the employee is from area A. Okay, so this is area A that we've got here. You really do need to label this as much as you possibly can do. So we need to figure out some different numbers. We need to figure out this number, this number, this number, and this number. There are 4 numbers that we need to find out. And this is where you have to be very careful about what these things are. Okay, I'll tell you what, I'm going to call this one, let's call this one number 1, number 2. Obviously, we're going to erase these at the end. So for number 1, Tell me about the person who would be in that group number 1. Tell me as much information as you can. If I got part B wrong, I'll fix it in just a second in case I've made a silly mistake there, okay? Home, area B, not professional. Good. So they need to be working from home. They're not inside area A, which means that they are in area B, and they are not a professional. They are not a professional. So I'm looking for people who work from home in area B who are not professional. People who work from home in area B who are not professional. So I think that's going to be just the 36 and the 4, which is the 40 that should go in that part, okay? So I can now say this is 40. Now, number 2 that we've got here, again, it's like trying to make things as easy to figure out. This is in all 3 groups. So they are in area A, they work from home, and they are professional. Area A, home, professional. Area A, home, professional, 481, okay? So again, you might do this in a different way, but I'm trying to offer you different ways of how you might answer this question without getting really stressed and confused. Labeling things, putting extra information on the diagram, writing down these little instructions of what we're looking for. Now, number 3 is inside A. They're inside professional, so they are area A. They are professional, but they do not work from home because they're not inside that group. So area A, professional, and not home. Thank you very much to 6. That's very nice. Thank you for calling me that. That's lovely. So we're going to say, oh my gosh, am I going to be able to do this without erasing everything? I said area A, not working from home, and professional. So 259. Now, if you want to, you could do 1825, the total amount, and subtract all of those numbers. I'm going to just try it this other way. Number 4 is area B because it's outside area A. They are not working from home, and they are also not professional. You could do just a total amount minus all of them, but that's going to be area B, not home, and not professional. So area B, not working from home, and not professional, 54 and 76, 130. Now, I am going to check this before I continue just to see if I got this right, because those numbers could ruin the rest of the question. Oh, I didn't even check this one, did I? But we did. Or did we? We did get the critical region of this. That was fine. That was fine. That was fine. Okay, so did I make a mistake for this one? No, it's 34 out of 365 and a 5th. 34 out of 365, that was correct, and a 5th. And then it's 40, 481, 259 and 130. 40, 481, 259 and 130. I just think the wording of that question is so crazy. So definitely relabel these things if that's helpful for you to do, okay? We are now going to do the last part of the question using the Venn diagram. So we're going to find the probability that it is not R and F. So not R and F. This is R. So it's going to be not inside R, but it is inside F. It's those ones. That's 247 and 133. That is 380 out of 1825. 76 out of 365. And then this one is weird. This one is H, the union of H or R, but the flip side of that, because it's got the not that goes with it. Okay, there's lag. We'll be back. This will give me a chance. Okay, people are saying it's not lagging anymore, which is good. So it's probably going to be back. So when you do this, this is the union of H and R, but it's the complement of that. So the union of H and R is all of this. This is H and this is R, everything that's inside both of them. So it must be everything that is not inside of both of them, which is the 133 and the 130. 133 and 130. 133 and 130, which is 263. It is 263 out of 1825, which can't be simplified. And then the last one, we've got a given that kind of thing. Now, I like to do, when I've got a Venn diagram, like a kind of reduced sample space. So we're saying, given that they work from home, what's the probability that they are a professional? So given that they work from home, how many of those ones are a professional? Well, all of them that work from home, there is 40, 1, 2, 3, 4, 8, 1, and 2, 4, 7. It's out of 891, okay? So it's going to be out of 891 because we're zooming in on that part. And how many of them are professional? Well, that's the 247 and the 481. That's 728 out of 891, which can't be simplified. And I don't think I've made any mistakes with this. You can definitely use pencil for things. So I definitely would want to be using pencils for this kind of stuff that we've got here as well. Okay. So let's have a quick look. We have the 728 out of 891 for the last question, with the 263 out of 825, and the 76 out of 365. Yeah, we've got all of those correct. So, like I said, if you do want a bit more input with this kind of stuff, then you can always get my Aiming for A Star session that is linked in the description. £15. You've got a couple of days to work on that for mechanics or statistics. £15 for each. Pick whichever one you want to do, or pick them both. Should be pretty good. We are finally on the very last question, which I don't think is that bad for a last question that we've got here. I actually think it's pretty straightforward. Anna is investigating the relationship between exercise and resting heart rate. She takes a random sample of 19 people, I always write this down immediately, in her year at school and records for each person their resting heart rate and the number of minutes spent exercising each week. Her results are shown on the scatter diagram. Interpret the nature between H and M. Well, it looks here that there's negative correlation, but they've asked us to actually interpret this kind of stuff, which means we need to say what is going on here. So it looks like as M is getting bigger, H is decreasing, but we want to put it in the context of the question. So we will say, as the number of minutes spent exercising increase, or something like, I don't know, the higher, I'm going to say, the more minutes spent exercising, the lower the heart rate. Let's say the resting heart rate. And I'm also going to say that this is H, and I'll say this is M. I want to give the examiner absolutely no reason to deduct me any kind of marks. I've included M, I've included H, I've included the context. I've done absolutely everything for this kind of thing, okay? So it then says Anna codes the data using these formulae. And this is where this has not been assessed in regular maths. Remember we said that there was like loads of topics we were expecting coming up. I'm not going to go through all of that again. This is something that is exponential to linear data. They did not assess this in normal maths. Does that mean it could be coming up? I mean, who has a clue anymore? At this point, who has a clue after what's happened with papers all being like different and stuff like that? Okay. So the product moment correlation coefficient between X and Y is this, negative 0.897. Test whether or not there is significant evidence of a negative correlation between X and Y that we've got here. So we're just going to see if there's a correlation between them. We don't need to worry about the logarithms or anything like this. We state the hypotheses, we use a 5% level of significance, and we state the critical value that is used here. Okay, so for part B of the question, the null hypothesis is that rho is that. They've said, is there negative correlation? So that's why we're saying it's going to be a one-tailed test. It's a 5% level of significance, which I'm saying is alpha. N is not 15. There were 19 friends, weren't there? So it's going to be 19 friends. So I will find the critical value from the table. Dun, dun, dun. Sample size 19, 0.05 is 0.3887, 0.3887. Because we're looking at negative, we can put it with the negative in there. Or what you can also do is just take the magnitude of our value. So our R was minus 0.897. And we can see that the magnitude of minus 0.897 is greater than 0.3887. In other words, it is strong enough. It is beyond that critical thing of what we've got here. So this means that we can reject H0. So there is evidence to reject H0. There is negative correlation between X and Y. And I think in the mark scheme, they don't even have like much detail about this. They just say, write down the critical value and then write down the conclusion. So if you get yourself all confused with this, then that's fine for this, okay? So, I always like to try and see what's going on in the chat. And then we've got the easy part, 5 marks. I cannot believe this is the last question of the stats paper, and then we'll wrap up this live stream. The equation of the line of best fit of y on x is y equals minus 0.05x plus 1.92, and we want to show that it is a model for h on m in the form h equals am to the k, where a and k are constants to be found. So for part C of the question, they've said that y is equal to minus 0.05x plus 1.92. But I'm going to rewrite this because they've told me earlier on that y is log h and x is log m. So this is log h and this is log m. Now what I do is I will be comparing this to h equals am to the k. What is going to be my first step for this? H equals am to the k. What's going to be my first step for this? By the way, we knew to reject this, the h0, because we had a significant value. Our value was in the critical region. It was bigger than 0.3887 for this. Of course, we're going to log both sides. So I get log h equals log am to the k. We know that this splits on the right-hand side to a log a plus log m to the power of k. But that power of k, I'm going to put down to the front like this. And then we just do a quick moment of spot the difference. They both have a log h. They both have log m. The thing that's next to the log m is the 0.05, and the k is that. And then the last part, the 1.92, is the log a that we've got there. So we're making sure that everything is matching up in the way that we want, which means that k is minus 0.05. And log a, remember the base is 10, is 1.92. So this means that a is 10 to the power of 1.92. 10 to the power of 1.92, which is 83.2 to 3 significant figures. So it means our final model is that h equals a times by m to the power of negative 0.05, like this, okay? In mechanics, you should always use 2 or 3 significant figures for this one that we've got here. I have no idea how this is 5 marks. This would be nowhere near 5 marks in a normal paper. It's very, very strange. I agree, stats is either impossible or really easy as well here. So let's just double check the mark scheme for this. We have got, they did want this minutes of exercise and they wanted heart rate. So exercise and heart rate had to be mentioned. Or they could talk about these kinds of things, but I think that first part makes sense. These were the things. The critical value, you're allowed it with plus or minus, and then go straight to the conclusion that we've got there. I did the method that's on the left-hand side. Now, I don't know why they've got answers which round to 83.17, because it doesn't. It actually rounds to 83.18, so they've obviously done something wrong in the way that they've typed it in their calculator. But down here, it actually should be 83.2. as that correct answer for this bit that we've got here. Okay, I will put this annotated version that we've got here. I don't think there's any other questions, are there? No. I will put this into the link in the description, and also linked in the description is any of those sessions that you might want to come to as well. I am so tired. I've actually got a really sore throat today, so I need to make sure that I rest it up a little bit before I do the last big live stream of tomorrow as well. And if you are a graphic designer, if you're an arty kind of person, I am going to be doing a competition about designing a bit of Bicen Maths merchandise where I will not be making any profit from it. I will give half of the profit to a charity and the other half of the profit will go back to the designer of whoever designed that. The live tomorrow I am planning for 3:30, okay? Grace, another one. That's amazing. Thank you so much, Grace. And you've been picking some very cute emojis that go with this as well. Okay. Thank you very much to Oscar for saying a round of applause. And I will be seeing you guys in tomorrow's session. Okay. I really hope that you come along. I hope you like these things. I'll try and pick some mantras that are sort of stats and mechanics related and stuff like this. I think the only way they could get integration or differentiation into statistics is if they have something with some kind of graph and you're trying to like, they did it in the past where there was like a frequency polygon, and if you integrate under the frequency polygon, you find the area. So maybe they could do something like histograms and finding the areas, something like that kind of stuff. So yeah, it's good. You can use a highlighter in the exam, but you should never highlight your own work. If you highlight your work, it gets completely blocked, or it can get completely blocked, which is why it's better not to use the highlighter for this as well, okay? I doubt we will be seeing an integration by parts question like it was in 2023, but who knows? What I think doesn't really matter. What matters is what's on that paper at the end for this. Oh yeah, Ali has said, remember there are 2 points of inflection on a normal distribution curve. You'll never have to differentiate it. I think the points of inflection, I need to check this. I literally need to check this right now. So where are the points of inflection? Because it's actually in the specification. I think they're... Yeah, a standard deviation above and a standard deviation below is where the normal distribution goes from being concave to convex, when it's the mean plus the standard deviation and the mean minus the standard deviation, which has never been assessed, but it is in the specification as well. Live stream tomorrow is at 3:30. We have basically done a full 1 hour stream for this. Go and get yourself ready for whatever you've got tomorrow. If you've got FP1, wishing you huge amounts of luck for that. And then I will put together some questions for what we'll do in tomorrow's session. And that'll be the last live stream. That'll be the last live stream. Maybe I'll do a live stream on results day to hear how things have gone, something like that. I don't know. We'll see what's happening. I will answer some of those questions that you've got there, Regia, as well. I'll answer that like in tomorrow's session because my throat's a bit sore. So I want to give myself a little bit of a break with this kind of stuff. Okay. Have a really good evening, guys, and I will see you soon. Thank you to my moderators. Ali has been in here. I don't know who else has been in here, but I've noticed Ali a lot. I think Karan was in here as well. They haven't had to do too much, I hope. Everyone's really good in these things. But just thank you so, so much for my moderators. I don't know what I could do or what I would do without them. And thank you to my mum and to my sister, Claudia, as well. It was, I don't think they're there anymore, but I know they were at the beginning. And go and check out my sister's art, claudiabicen.com or claudiabicen.com. You'll see some really cool artwork that she's got there. Have a good evening, guys. Bye now.